it's Rhoda from the West Springfield Public Library. Whether you call this slime or flubber or oobleck or gack, making slimy substances is proven to be extremely fun and fascinating for kids and for adults of all ages. The commercial slime was invented by Mattel Toys in 1976. While creating slime, the toy company wanted the oozing substance to be as gross as possible, and thus the slime was first created in a light green material, which could be found in a little green trash can. The trash can toy was sealed with a lid to keep the slime fresh and ready to use. Children all around the U.S. loved this oozing slime. So what's the science behind slime? Well, I'm sure you're all familiar with various slime recipes, but you might not be familiar with the basic slime science. Slime science starts with the best slime ingredients, including the right kind of glue and the right slime activators. The best glue is PVA, or polyvinyl acetate, otherwise washable school glue, either white or clear variety. You have several types of slime activators to choose from, all from the boron family. These include saline solution, liquid starch, and borax powder. All contain similar chemicals that are used to make the slime substance. Slime is a non-Newtonian fluid. Sir Isaac Newton is a famous scientist from the 17th century who came up with 3 ideas that are applied to the physics of most motion. Slime, however, does not follow those rules. Non-Newtonian fluid is neither a liquid nor a solid. It can be picked up like a solid, but it can also ooze like a liquid. Slime does not have its own shape. You will notice your slime change its shape to fill whatever container it's placed in. However, it can also bounce like a ball because of its elasticity. Pull the slime slowly and it flows more freely. But if you pull the slime quickly, the slime breaks off more easily. That's because you are breaking apart the chemical bonds. What makes slime stretchy? Slime is all about polymers. A polymer, the Greek word poly, or many, and mer, meaning parts, are made up of very large chains of molecules. The glue used in slime is made up of long chains of polyacetate molecules, and that's why we recommend PVA glue. These chains slide past one another fairly easily, which keeps the glue flowing. Chemical bonds are formed when you mix the PVA and the slime activator together. Slime activators change the position of the molecules in the glue in a process called cross-linking. Think wet, freshly cooked spaghetti versus leftover cooked spaghetti. Cross-linking changes the viscosity or flow of the new substance. Now, there are many recipes for slime out there. Some slime is runny and liquid-like. Other slime is thick and rubbery. Some slime glows in the dark, and some slime is fluffy. Some even is color changing. This is the slime we're making today. This slime is so much fun, we couldn't stop playing with it. Hot hands, cold drink, the sun, all make the slime change color. It's heat-sensitive, color-changing slime. And there's some pretty cool science behind it too. The scientific term is thermochromism. Thermo is the Greek word thermos, meaning warm or hot. Chromic is the Greek word chroma, which means color or pigment. When the heat is applied to the dye, the molecules absorb and or reflect specific colors of visible light at different temperatures. In your bag, you'll find the following materials. 1 container with a slightly green solution. This is 1/4 cup of clear school glue with 2 teaspoons of thermochromic powder already added. The thermochromic powder is hard to mix, so that's why we've added it in advance. 1 container of 1/4 cup liquid starch. 1 larger plastic cup to stir the combined solution in a wooden stirrer. Pour 1/4 cup of glue into the larger cup. Add half or about 1/8 of a cup of the liquid starch and mix until thick and slimy. Then knead the slime with your hands. We found the mixture starts out as a very stringy spaghetti-like mixture. We kneaded the mixture for about 5 minutes to combine the polymers. Then we let the mixture sit for 5 minutes and then we kneaded the slime again. This step is important because it makes sure that the glue atoms are forming bonds with the activator. If the slime is still sticky, add additional starch, a little bit at a time, and knead until it's not sticky anymore. You can store the slime in a plastic container with a lid or a Ziploc bag for up to a week. Now here comes the fun part of thermochromatic slime, experimenting. Place the slime on something cold, like the side of a canned drink that's been in the refrigerator or an ice cube. What do you observe? Does the slime get darker? Now hold the slime in your hands or place it on the side of a warm glass of water. What do you observe? If the pigment is doing its job, you should see a distinct color difference between the cold slime and the warm slime. Another experiment that you might want to try, take a little bit of your slime, put it in a cup, and add some vinegar. You will see that the bonds start to separate. After you finish with the vinegar, go ahead and add some baking soda to the same mixture. It might not look quite the same, but you'll see the bonds starting to form again between the glue and the activator. Fun? I hope you've had fun with Science Rocks during this summer session. Hope to see you guys in the fall. Until then, happy reading.